Okay, so I think we're almost ready now to remove that capacitor that's in there. But first, let's make a few observations since I have the camera close-up going quite nicely here. When I look at this resistor, I see this upper part has no dust on it, but the lower part has a lot of dust on it. And you can see the terminal it's soldered to and the other wire coming from it also have a lot of dust buildup on them. So I mean, that's clearly a high voltage terminal. And I think, again, across the resistor you can actually see the voltage drop across it, kind of. So again, it just shows that you can analyze these circuits just by looking at the dust on them. And I look at a fair bit of dust on this capacitor too. And you can kind of see this resistor is definitely darkened down here, and I think it's biting the dust because of leakage problems from these capacitors. Not quite sure about how this resistor is biting the dust, though. Really have to look at that closely. So let's go after this capacitor now. You see how they've got them in here. Bare leads just physically spaced here. Hey, what size capacitor is that anyway? I certainly can't be taking it out until I know it. I guess once we get it out, we'll see. So, I'm going to cut the leads off here. Just a little awkward with the camera in tight like this. Okay, so here's our capacitor here. It's a 27,000 picofarad, which would be, it's kind of a weird number, 27 nanofarads, which would be 0.027 microfarads, I believe. 0.025. 0.025. 0.0, let me write it down because you know, before you know it, I'll be changing the 0.5 to something else. 0.05, 0.05, 0.025, 0.025 microfarads. That's what I think that is. It'd be interesting to put this on the, where are you there? You're way down here. Put this on the tester, put some high voltage on it and see if it leaks. So we'll do that one first. 0.025. 0.025. Well, what if I put a 0.02 in there? Or a 0.03? I have no 0.03s. So it's got to be a 0.02. 0.02, 0.025. It's a difference there, but it's not really a great difference. It's mainly a blocking capacitor and signal capacitor, so I think we'll be just fine. We really do need to stop the leak. That's for sure. It'll be interesting after I put this in there if we still see the voltage, because I don't have an operating tube in this socket. Which might explain why I'm getting strange voltages. Yeah, this is going to be just a little awkward for me. Because the camera's right in here tight. better put some spaghetti on the wires here. Now, just shaping the wire here so it'll go in. There we go. Ah! Believe me, you got a much better view of this than I do. A much, much better view of this than I do. Come on. You've got a view way better than what I can see here at this point. Ah. Okay, let's solder that in place. Everything gets a lot easier once one lead is connected. Oh, my soldering iron is really hot. I think I turned it up on full to heat it up fast. And I think I left it that way. Whoa. Yeah. That's one hot soldering iron. I think it would glow red in the dark. Did I get it? Yes, I did. Now we'll go for the other leg of it here. There we go. I want it to go like that. I guess often I'm comparing this kind of work to surgery, and I realize it's not surgery. Maybe it's more akin to dental work. You have to work in these small, awkward places. And I wouldn't compare this to like automobile repairs or anything like that. I think that's really very different from this. The scale of it and all that kind of stuff. Or, say plumbing or house repairs or anything else. Okay, that's good. That's in there properly. Might as well do the other one right away. While we're in here. Get another 0.02. We'll take the very same approach with this one. Connect the lower lead first. Okay, in it goes. Yeah, there's more than just a camera in the way here too. There's the radio itself is kind of in the way. Oh boy. Okay, get on there. Yeah. You have to wonder when I'm doing this if there's some tricks I don't know. And the answer is probably yes. To making this easier. One of the tricks would be don't bother filming this stuff because the camera's in the way. That would make it easier. Seems to have barely got on there. Boy, if that doesn't short against the other wire there that it's crossing, it'll short onto the chassis. It's really a bad situation there. Okay, let's see if I can solder that right there. Well, how's that look in the camera? Well, I can get a little more solder on that lower connection. a little bit better. Do the other one again too. I think that's a little bit better. Okay, nothing shorted. That's the two capacitors. Let's check out and see what kind of difference we made here. Yeah, that's the apparatus you were on just now for that camera shot. Gotta get creative here, you know, to get this to work. Now, the question would be, have we made any difference? Or is it just because I've got a non-functional tube in the circuit that we're getting these weird readings? Okay, so just a quick check. Everything looks good. Nothing stupid going on. Let's put on the power. Just keep my eye on this meter here. There it goes. Okay, watch this guy here. Starting up here, we see nothing. Coming down here, nothing. So, on the other side, look out, baby. Lots of voltage there. On the other side, not nearly as much. So we got to check out what is going on here a little further. Now, let's see. This is where the tube is operating. And this is where the tube is not. It could easily be because of the non-operating tube. If we take a look here, we'll figure out where we are on this thing. Right now I'm reading pin number, I guess that would be pin number 8. Pin number 8 is a cathode. Pin number 8 is a cathode. It's a cathode on the triode. It's a cathode on the triode side. It's a cathode. There is a resistor here. Let's look at the upper one. It's easier to see. Right here. Look at the difference here. Am I doing the right thing? Okay, if I pick this terminal, you see the tiniest positive voltage. And if I pick the same terminal on the other tube, wow. Now, that could be because this is a defective tube here, or yeah, non-operating tube. Does that make sense? If that's the cathode, and there is a cathode resistor, and there's no current flowing through it, this should be hard to ground. But of course, there's this resistor, and this one. So this one's baking right now. I think this is hot right now. Hot thin, she's hot here. Baking, baking, baking. Where did I get the 50 there? You see the 50 show up suddenly? You know what? That's that resistor. That resistor is baking right now. Do I dare to touch it? Don't have to touch it. I can feel the heat coming from it. So there is a problem there. Now, that terminal has two resistors, one to ground, and the other one, yikes, it's going over to the speaker. What is going on there? It's
I wish I had a schematic, you know, this would just be so much easier.
well. I think I'm gonna stop the camera, study the situation for a little while, and see where we're at with this, because we're making headway. Got rid of one positive voltage, got another one to track down there. This, you know, oddly enough, these problems are occurring on the socket that contained the working tube. The blown tube is in the other socket. But these kinds of problems can ruin a tube. There's no doubt about it. Quietly ruin the tube. So we'll see you in the next video as we continue on trying to figure out what's going on with these output tubes.